Since the 1940s, methotrexate, known as MTX, has been used as an antimetabolite to block cell proliferation in neoplastic diseases. While the rationale for using MTX to treat rheumatoid arthritis was presented in 1951, it took another 30 years before the results of well-designed, placebo-controlled studies were available. Interestingly, the precise mechanism for how MTX works in rheumatoid arthritis has not yet been fully elucidated. However, a growing body of evidence suggests the mechanism of action of MTX in rheumatoid arthritis might be its anti-inflammatory effect rather than its anti-proliferative effect. These anti-inflammatory mechanisms may result in clinical effects such as rapid clinical remission, short-term effect on acute phase reactants, and rapid disease flares after discontinuation. Let's take a closer look at how the anti-inflammatory response might occur based on preclinical studies. Extracellular MTX is actively transported into the cell. Intracellular MTX is then polyglutamated, which converts the molecule into its active form. MTX glue inhibits a variety of different folate-dependent enzymes, but ACAR transformylase is the enzyme it inhibits most effectively. Polyglutamated MTX inhibits the enzyme ACAR transformylase. Because ACAR transformylase activity is blocked by MTX glue, ACAR molecules can no longer be broken down. The result is an accumulation of ACAR within the cell. With an increase in ACAR within the cell, the levels of adenosine also begin to rise. Adenosine is an important molecule that has an anti-inflammatory effect. As adenosine accumulates within the cell, it is released into the extracellular space by exiting through the cell membrane. Extracellular adenosine is available to then bind to any of the 7-pass transmembrane adenosine cell surface receptor types, including A1, A2 alpha, A2 beta, and A3. These are found on the surface of a wide variety of different cell types. Adenosine binding to cell surface receptors helps regulate the inflammatory response by inhibiting the production of several key pro-inflammatory cytokines. As the level of pro-inflammatory cytokines lessens, the inflammatory response is also reduced. Although the full mechanism of MTX in rheumatoid arthritis is not completely understood, adenosine accumulation and release are thought to play a major role in its anti-inflammatory properties. The adenosine-mediated anti-inflammatory effect of low-dose MTX is well supported by in vitro, in vivo, and clinical data.